now we're done with what rolling is, and then what we need to do next is to solve problems with rolling objects. So let's start with just giving you a guide on how to solve objects that are rolling. So here's again a problem-solving guide. Similar lang din to sa ginawa natin last time. So again, we first draw an extended free body diagram showing the shape of the object and the forces, the point where the forces act. Importante again now is kung saan nag-act yung mga forces. Okay, do not forget that. Hindi, sa particle, it will always act on the single dot. For rigid bodies, it will act at different points on the rigid body, depende. Please check kung anong forces yung mag-act dyan at kung saan siya magpo-point. Okay? The second one, again, is you use Newton's second law to relate the forces. That is, again, we're dealing with planar rotations until now. Kaya nga hindi dapat magbago yung center of mass, yung direction ng center of mass velocity, because we're still dealing with planar rotations. And hence, if we use Newton's second law, dapat nasa x and y directions lang yan. And then after that, for possible rotations, because definitely we will have calculations involving the torque exerted on the rigid body, we use Newton's second law for rotation, which is summation of all torques will give rise to some angular acceleration alpha. Okay, and then again, as a rule of thumb, pag ang hinahanap ay torques, forces, or accelerations, what you need to use is Newton's second law or Newton's second law for rotation. Otherwise, if you want to determine angular velocities or linear velocities or distances or displacements, what you want to determine or method you want to use is you need to use your energy relations. Like for example, this. Now, sir, di ba may friction yung ano? Bakit pwede kong gamitin itong mechanical energy conservation? Di ba? Frictional force yan eh. May static friction ka. Yes, exactly. It's just static friction that's acting. Hindi kinetic friction. Therefore, there is no work that's done by friction on the object. Kasi at rest nga siya at a certain point. At the point of contact, at rest yung object. And therefore, wala dapat work na kinakonduct yung static friction. Hence, mechanical energy is conserved. Okay? Questions? Questions? May tanong? Wala?
None po.
And then after that, after using these equations, usually systems of equations and as usual. And then after that, you need to substitute and solve for the unknown quantities. So, okay? Questions? May tanong? Wala? Okay. And then after that,
None.
for an object, this shouldn't be tangential. This should be center of mass. Sorry for that. For an object rolling without slipping, the velocity of the center of mass is related to the angular velocity. Again, we are assuming a non-slip condition, a relatively special non-slip condition, which involves the velocity of the center of mass, not the tangential velocity. Again, similar, well, of course, equal naman sila. Pero at different points, nag-iiba-iba yung tangential velocity. Now, for an object rolling without slipping, the acceleration of the center of mass is related to the angular acceleration. Sorry for this. Para na-edit to. Angular acceleration. Okay? Questions? May tanong? Similar with a VCM, we have ACM also. Questions? May tanong? Wala? Okay, wala naman ata.
None, sir.